Okay, so when we're doing this problem, which here's the prompt for the problem, it says the following diagram shows cross sections of a flower vase. Approximate the volume, approximate the curved edges, show the line segments you would use to approximate the figure. And one of them, like, I'm just going to show you a couple of your responses because some of them are really good. You can kind of see like that this person here, they just go from point to point, point to point. This is a really good method. This is way precise. And then do you notice, like, say this person's here? They just made shapes that were really familiar. So this person here does this really cool thing by making shapes that are familiar, like rectangles. So I want you to remember, like, back in the day when you were, I don't know, you were, hold on a second, let me grab my thing. When you were in, what is that, fourth grade, fifth grade, maybe? And one of the things that they would ask you is, can you find the area of this shape? And the shape of it would be like kind of funny. So hold on, let me get here. So let me get to where we are drawing. So they would have some weirdo shape and it would look like, I don't know, the classic one is always going to be a square, and then they have a circle, and then they have this part shaded out like this, right? Right. So they say find the area of the shaded region. So what we're doing here is this thing, but to the high schooler. Does that make sense? So if you ever notice the things that we're doing, I'm always saying things like, because if it works in Numberland, then it'll work in this land. And because it worked in, before in fourth grade geometry, it's going to work in 11th grade or 10th grade, whatever grade you're in geometry. Does that make sense? So one of the ways that you can certainly do this is by cutting these up into shapes that I know and then can revolve and then find the area of, right? So let's just do one of the ones that your classmate said was, I'm going to cut this into this shape like this, right? You guys all see this right here. And then Miss Johnson, why aren't you drawing the other side? So I'm going to dot that in as in this will show up once I revolve it around the x-axis, right? Do you guys all see my little shape there? So once I revolve this around the axis, this thing actually looks like the shape that we learned before, but it doesn't have to be this precise, because remember, if you remember how we found this was called a frustrum, right? If you to find the area, the volume of the shape, you had to do cone minus cone. Do you remember the cone minus cone? It doesn't have to be that exact. In fact, if you wanted to, you could draw this shape in, because they asked you to approximate the volume, right? Approximate. Now, someone who does this fuchsia pink shape is going to have way more of an accurate answer than someone who does this rectangle shape, right? But just so that you guys can see different shapes, I'm going to show you, and then you'll understand, like, oh, I get it. So when I find the volume of this guy here, okay, can you all imagine my rectangle? Do you guys all see my rectangle shape right there that I got? And some of you are like, can I just go all the way across, Miss Johnson? Absolutely. But I'm just going to start with this just so everybody sees. So what shape would that be if I took this rectangle and I rotated it or revolved it? Is it revolve or rotate? It's revolve. Sorry. Revolved this around the x-axis. What shape would be sitting in front of you? Which shape would be sitting in front of you? So again, be comfortable with talking out loud. Let's be wrong. Okay, here, I'll throw out a wrong answer. It's going to be a ball, Miss Johnson. It's a ball. No, it's not. There's no way a rectangle, when I revolve it around, it's not going to give me a ball. Is everybody comfortable with it? Yeah. So someone says, hey, Miss Johnson, it's a cylinder. Exactly. So if you can't imagine that cylinder, I'm just going to scooch over here. Scooch. So imagine taking this rectangle, and then number one, your first strategy was to reflect it across your x-axis, right? So I get that shape. So that's actually my cross section right there. That's me cutting that shape in half. Okay, so I cut it in half. But then I actually want to draw it out. So it's actually going to look like this. So I'm going to use a different color so maybe it stands out a little bit more. So it's going to look like this. And then it's going to look like this. And then this part back here is going to be dotted. So it's going to look like a coin. Does everybody see my coin right there? Again, Miss Johnson, she is like the best artist in the world. And I know you all think, man, why are you just a teacher? You should go out there and share your art with the world. No, I'm just kidding. So this is a cylinder, and we all know, if you don't know, it's okay. You can find the volume of a cylinder. If you don't know the formula, it's totally okay, but it's pi r squared h. So you need to find the r and the h of this cylinder, and then you can repeat that process over and over and over and over again, finding an approximate of this vase, right? It's just going to be an approximate. Now, for those of you who want to do a more exact calculation of this, you are using that frustrum. But notice here, I'm doing one calculation of the cylinder, and I got it. For here, you would have to do cone minus cone, which is not that big of a deal because you have a calculator, right? Who cares? So what is your radius for this? What is your radius for this cylinder that's right there? What's your radius? Someone says 3. I don't know. I don't know about that 3. Can you guys all look to see if you agree with that 3? Look to see if you agree with that 3. And if you agree with that 3, awesome. If you don't agree with that 3, ask yourself why that doesn't make sense to you. Ask yourself why it doesn't make sense, because all I'm going to do is I'm going to build on this. I'm going to do this over and over again. So if you can do this once, do you see I don't really have to do this over and over again with you, because once I teach you once, I'm just going to add all these together. Does that make sense? So I don't need to walk through all of these with you. I just need to do it once, maybe twice, just to make sure that everyone's on the same page, and then we're good. Okay. So if you're okay with 3 comes from here, the rectangle. The rectangle's height is 3. Therefore, the cylinder's radius is 3. Does that make sense? I'm going to say it again. The rectangle's height is 3. See, it's 3 right here. I don't know why I'm not writing it in. And so therefore, when I pull this, actually, I'll write it in here. So when I pull this over here, there's that rectangle and there's that 3. And then if you picked up that cylinder and you looked at it, you would see that the radius of that, again, radius is from center to edge, is going to be 3. Okay, so now you have to figure out the height. Now the height of the cylinder, I know that you guys all measure yourself as height as vertical distance, but really it's perpendicular to, your base. Your height of this cylinder is going to be perpendicular to your base. So it's actually this way. Do you guys all see this guy? Okay, so I need to know what the height is. Oops, I messed up. Okay, I need to know what my height is. I'll do it in this red color. What's the height of this? What's the height? Yeah, people are saying 1. Miss Johnson, my height is 1. Why is that? So bring yourself back to the rectangle. That's the, I don't know, I don't want to call it base, but that's the length or the width of your rectangle, right? So that becomes your height, and then I'm done. Right. So I like to leave my answer in terms of pi because I am a mathematician. Mathematicians like precise answers till the very end. I would never take my answer to Home Depot and say, hey, can I get 9 pies worth of fence? They would look at me like I'm cuckoo, and I wouldn't do that. So I would actually multiply out before I went to Home Depot just to make sure. But for Miss Johnson, because she's a mathematician, I want my answer to be exact as possible. Please think about this. Every single time that you hit enter on your calculator, your error gets bigger and bigger and bigger. So for those of you who are going to be engineers, your answer cannot have an error multiplied by how many times you hit enter into your calculator. Otherwise, your margin of error goes from 0.001 to 0.1. And some of you are like, Miss Johnson, who cares? It's not a big deal. Actually, it does. In the engineering world, that's a big difference. Okay. All right, moving on. So do you see how you could just repeat this process over and over and over again? Is everybody confident with that? Yeah, because all you're doing is you're You're measuring cylinders. For those of you who are going to do cones, even better, because now your answer is even more precise. Ms. Johnson, are you ever going to make us do rectangles versus frustrums or cylinders versus frustrum? No, I'm not. But I do want to show you this person's here. Okay, so in case you don't know, MC Escher is a really famous mathematician and artist. If you haven't seen his drawings, they're really, really good. But anyway, so this person just makes two shapes. Look, two shapes. Boom. This rectangle looking thing, and boom, this trapezoid looking thing, right? This person is like, boom. Some people are like, man, that person's lazy. I call this person very efficient, right? Ms. Johnson, can we do this? Yes. So then you would have to know that your approximation, I will ask this, is your approximation over, under, or just right? When you calculate this volume and you get an answer, is this over, under, or just right? So this is the Goldilocks and the Three Bears, right? Is this over, under? Yes, it's over. How can you tell it's over? How can you tell this is over? How do you know that? What tells you that this is over? Like over. How do you know that this approximation that this person's going to do is over? Yeah, because we went beyond the vase. We went beyond the vase. Now, let me ask a different question. This person, where are you? This person. Ooh, look at all this beautiful stuff. Boom. Okay. This person here, over, under, just right. Over, under, just right. And who's closer? This person or the person with the rectangle trapezoid? Who's closer? This person or the person with the trapezoid and rectangle? Yeah, this person's way closer. Now, because this person's way closer, notice the math that this person is doing, pretty intense, right? This person, when they revolve this, they're going to be revolving a rectangle once, which turns into a cylinder, and a trapezoid once, which turns into a frustrum. So it is your choice to choose, but I want you to be comfortable with knowing that, and you would say this in your answer. This is an approximate. I know this is going to be over. I'm comfortable with it being over. Yeah. So here's what I don't want. Here, like, don't do this because this is too much, right? So here, let me grab this. Like, let's say you're like, oh, Miss Johnson, she said to use shapes. She showed that person was really efficient. What if I did this? Right? What if I did this? Is this okay? You guys are like, that's really cool, Miss Johnson. But this is not okay. And I'll say this is not okay because they asked you to, back here, they asked you to approximate the volume of the vase by using line segments to approximate the curved edges. So I'm not doing a good job of that. Unless you went in and then you started subtracting off this, we call it white space. White space. This is called white space. Does that make sense? Okay. Is everybody okay with that? This is called white space. In the world of marketing, right? There's a lot of white space. Have you guys pay attention to white space? And it's pretty neat. I want to show you a couple of things on white space. Has anybody ever seen this? Wait, where is this? This is white space. So pay attention to the white space and see if you see what they wanted you to see that you never noticed. That now you can never unsee. Look at the white space in the logo of FedEx and see if you see what they wanted you to see that you never saw before. Yeah. How many people saw this arrow right here? Before we pointed it out completely on your own, you were staring at a FedEx truck in front of you and you're like, boom, there's an arrow. I wonder if that was on purpose. You did. Oh, that's neat. So if you have seen this before. Wait, but not off like a YouTube and like, hey, did you ever see this before? Oh, you saw it from YouTube. Nice. I just said that. Okay. So it's very interesting. What about the Amazon logo? Does anybody see the Amazon logo? Amazon logo. Don't go to Amazon because then you will get into the vortex of shopping. Did anybody see this logo on Amazon? Anybody see the logo for Amazon? Anybody see it? Yeah. It's the smile goes from A to Z, which is basically what they're saying. Like you can get everything in Amazon from A to Z, right? So white space is very important. For those of you who have never seen that, that's not a big deal. I actually didn't learn this from looking at it. I think someone told me this. I think my daughter might have told me this one. But someone told me about the FedEx logo, and now you can never unsee it, right? But I think they did a survey of people and they said, "What do you see?" And they didn't see what they wanted them to see. So FedEx, poor FedEx, right? Um, so this is remember I told you about geometry. Your observation skills need to be like on point. So if you took out your white space here, then that's another strategy as well, right? It's another strategy. All right. So with that being said, I'm going to pull out our takeaways to make sure that you understand what you were supposed to take away from this lesson. It says strategic ideas for approximating the volumes of a solid of revolution. Number one, you can decompose a solid of revolution into intervals and create cylinders, frustums, and cones that approximate a portion of the total volume. So if I would have read you this before explaining this problem, or actually, sorry, like this, how you guys are now seeing it, you would all been like, what are you talking about? But now listen to this, right? Let's wait, sorry, my bad. Decompose means like pull apart. So if there was a Lego structure in front of you, decompose means to take the Legos apart. So decompose a solid of revolution into intervals, meaning sections, and create cylinders. We made cylinders. Some of you made frustums. Some of you, we used also cones to get our frustums, and then approximate a portion of that total volume, right? So the second part is determine if the shape used over or under. Do we all do that? Now we understand what over and under is, right? And some of you, I need to say this. I need to go back here really quick. Where's my, so we can see clearly this person's going to be doing an over, right? Nothing wrong with doing an over. Where's my under? This is more under. This one's going to be under. And some of you are like, but Miss Johnson, they go over here. But can you imagine the over here versus the under here, right? Can you compare those two? And you're like, oh, I kind of get what you're saying. The over here doesn't compare to your under here. Does that make sense? Okay, very good. And then you guys all learned about that how it approximates, right? Trap the actual volume between an underestimate and an overestimate. And this is what we're going to continue to work on. So when they say trap the actual estimate between the under and the over, what they're saying is is this. If we all got together and we did this, right? I would take this person's, which is an overestimate, really good drawings here, whoever did this, very good, which is going to be an overestimate, and I would go to this person's who's going to be an underestimate, and I would take those two numbers and I'd say, oh, the volume of this vase has to be between blah and blah, right? It has to be between whatever this person found, Cynthia Brazil, and this person here, or even this person. I can go overestimate in this way. So does that make sense in terms of trapping it? You're going to trap that number between those two values, okay? The more sections the volume of the solid is decomposed into, the closer the approximate volume is to the actual volume, right? When we compared these guys here, who's of these here, who's going to have kind of like the number that's approximated further away than someone else's? Which structure here is going to give you a number that's further away out of all of these? Put their name in the chat is what I'm asking. Yeah, right. Evelyn, Xing Shen, V Hart, MC Escher. All of you are going to have this over approximation versus, let's see, this person, Cynthia, is an under, and we are talking about that. Oops, I did it again. So the more sections you have, the more closer to the actual volume you will be, right? And some of you, I don't know if this makes sense, right? Some of you are going to understand this comment. Like this person sectioned it off. Where are we? This person. Yeah, let's do this person. This person sections it off into 1, 2, 3, 4, 5, 6, 7. Oh, wait, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Right? Can you imagine if I sectioned it off in this half section, right? And I went across this way and shaved off that little bitty right there. Do you guys all see that? I'm going to do it again. I'm going to draw on yours. It's not going to stay on yours. I promise not to ruin your work. But imagine if I cut this one like this. I should have used segment line. I should have. And then I cut it across into this little half section. And I'm just approximating. So I'm just going to pretend this is 2/3 of the way down, right? Do you see how I shaved off all of this section? Now my approximate's even closer. So the more tinier and tinier, I can make these like rectangles super skinny, right? I can do halves, and then I could do fourths. So do you see how skinny I can make my rectangles? And then by making them skinnier and skinnier, I am now getting my volume to be closer and closer to the actual. Does that make sense? Does that make sense? All right, good. Good. All right, moving right along to my takeaways. Okay, did that one. Defining a frustrum as the bottom slice of a cone is not very precise and needs to be revised and refined. So do you remember when we were talking about a frustrum, we drew it like this? Oh, geez, this is going to be interesting, Miss Johnson. That's pretty good. So can anybody describe this rather than just the bottom slice? How would you describe this rather than it's the bottom slice? How would you describe it? Very good. Very good. I have it's almost like if you do the cross section, it's the base of a triangle. Very good. The cross section is a triangle. Someone is using the word base, right? So one of the ways I would describe it is I would say cone minus cone. Cone minus littler cone, right? Cone minus top cone. But the book's definition says the portion of a cone that lies between the plane containing the base and a plane that's parallel to the base. What? So can you imagine that this cone is sitting on a piece of paper like this, meaning a plane? You guys all see it's sitting on my plane right here. It's a piece of paper. You guys all see my piece of paper here? Good. And I take another piece of paper that's parallel to this piece of paper. Ms. Johnson, can planes be parallel? Yes, just like lines, they don't touch. Planes can be parallel and they won't touch. And can you imagine that this plane is parallel and it contains the top base, the top of this frustrum. So that's that's the way they describe it. You can think about me taking two knives at the same time and slicing through a cone, and the slices are parallel, if that makes sense. Okay, let me just move on. And then this says, here's your definition, which I just read to you. And it says our volume formula for a frustrum is this, which I didn't have to teach this to you. This made sense to you, right? Because you guys said cone minus cone. Okay, so hopefully that all makes sense and we can close this section up. Any questions before I close this one up? Does it feel better? Doesn't this feel better than it when we started? You guys are like, we're going to be revolving stuff around us something and finding the volume. Like, what the heck? But not that bad, right? Very good.